Welcome to On Cloud, the podcast for cloud professionals, where we break down the state of cloud computing today and how you can unleash the power of cloud for your enterprise.
Hey everyone, welcome back to the On Cloud podcast. I'm your co-host, Gary Arora, Chief Architect for Cloud and AI Solutions over at Deloitte. Today we are shifting gears, pun intended, to talk about one of the most exciting trends in automotive industry, software-defined vehicles. Now, I have been genuinely fascinated by this topic, so I can't wait to unpack it with our special guest, Bob Monkman, Senior Principal at Red Hat. Bob, welcome to the show.
Thanks very much. I'm very happy to be here.
So last year, Red Hat and Deloitte announced this expanded collaboration to propel software-defined vehicles with pre-integrated solutions designed to build the cars and the capabilities of the future. So first of all, thank you for your partnership there. And second, I just wanted to ask you first to lay out the problem this solves. Because as users of automobiles, we take so much of the software for granted. We expect it to just work. And I can speak for myself. I am oblivious to the intricacies of the underlying software in a car. Can you shed some light on this software complexity and what is this problem that we are trying to solve?
Yes, absolutely. So it's really, a perfect storm of multiple factors happening in the industry. It's the move to electrification. So the entire vehicle hardware architecture and drivetrain is changing, but also that is in concert with that is a whole new software architecture that's required. Secondly, historically, the electronic control units or ECUs in the vehicle, there was up to 100 or more of these in every vehicle. All of them were built as black boxes with their own hardware, their own software, tightly coupled. And there's been a great deal of effort to consolidate the hardware, the compute elements, down to more powerful, high-performance compute is what we call HPC, compute platforms in the car. And also now that what happens in that design is that you have the consolidation of the applications or the middleware as well onto a more powerful compute platform. So that requires a lot of re-engineering of the software to be able to have safety workloads and non-safety workloads operating on the same compute platform, for example, something we call mixed criticality. That requires a great deal of software care and design to make sure that there's freedom from interference, for example, for the safety applications, right? So all of these things are happening. And finally, it used to be that the software was pretty much done and fixed and signed off when the car was shipped in production. But now, like in mobile phones, you have the expectation that features, security fixes, updates, new capabilities can be added after production throughout the life cycle of the vehicle. And so that means you have to establish a whole new continuous innovation cycle from the cloud, from the operations center down to the vehicle on an ongoing basis. So there's there's organizational changes, there's personnel changes, there's software architecture changes, and all of the processes therein. So, and business model changes. We'll talk about that a little bit later too, I think. So
you mentioned high performance compute and software consolidation, cloud updates. These are some of the concepts we discuss quite often in enterprise settings. It makes sense that we apply some of this to cars now, given the increasing complexity of software running on the vehicles. So how does the Red Hat Deloitte partnership help automakers reimagine software development processes and the continuous innovation deployed to vehicles?
Yeah, it's a great question. And really, when you think about what's required to completely change from integrating closed boxes into the vehicle, into a consolidated hardware software integration. Great question, Gary. So when you think about what's involved in this kind of a sea change in the way software is developed, the whole architecture, these organizations typically had not had to do, especially the continuous innovation, the notion of making changes to software throughout the life cycle of the vehicle. So this requires what we refer to as the establishment of a continuous software factory. It requires agile software development processes, what we call continuous innovation, continuous deployment, or DevOps processes. And so while Red Hat is delivering a lot of the core technologies at the operating system level and for containers and hybrid cloud technologies and automation, these teams really need new talent. They need new training. They need new processes. And so it's super important for this cloud to car continuum for the automakers to establish this software factory. And they're going to need help from companies like Deloitte to help them establish all of these new processes, new methodologies, and the software architecture. These are the kinds of skills and deep expertise that companies like Deloitte have to help the automakers get there, because they typically have not needed or had those skills in-house.
Right. And DevOps and containers for vehicles, this is a really fascinating space to be explored in the context of vehicles. And open source has been at the heart of Red Hat's approach. So how does this open source foundation enable greater collaboration and innovation within the automotive ecosystem? And perhaps what are some of the security implications of this approach?
Yeah, it's a common question. So, first of all, historically, again, much of the software deployed in vehicles has been proprietary from multiple different vendors, very bespoke, and tied very closely to the hardware, as we spoke about a little bit earlier. Now we have this opportunity to reimagine or rebuild the software architecture. And what's happening with this whole SDV transition in the industry is that there's numerous disruptors in the space, and they're taking a software first approach and really leading the charge in new ways, doing innovation throughout the life cycle. And so incumbent OEMs are really challenged to keep pace. And we at Red Hat believe, and this has been really well established in other industries as well, the pace of innovation of open source, just because of the sheer number of developers and the sheer mass of knowledge around open source and experience with open source from use in the enterprise world and telco and other industries, there's just so much talent out there and so many engineers contributing to open source that the pace of innovation cannot be matched by sort of small proprietary software vendors. So there's a pace of innovation there. And you might think that might have security implications or reliability implications, but in fact, it's been proven and well established that open source software is actually far more reliable and far more secure because of the many eyes concept, the notion that everything is in the open, everything is transparent. And so some people make a career of themselves in open source, ferreting out bugs or security flaws. And so this becomes quite effective. No one can go in and create, sort of a rogue security backdoor in open source before somebody else is going to spot it and find it. It's all transparent. It's all in the open.
And what about the functional safety, Bob? Many of the vehicles have to comply with the latest regulations. So how does Red Hat deal with the functional safety implications?
Yeah, so there certainly are requirements for functional safety in certain use cases within the vehicle. And that's been a hallmark of the whole effort with Red Hat to build an in-vehicle open source operating system. We felt from the start that it would be necessary for us to be able to comply with what is known as the ISO 26262 functional safety certification requirement up to level ASIL B. And so we've been working on that for several years. We had a press release last June where we made that first certification for a small portion called the math library of Linux to prove our approach, because it does take a novel approach with open source software that wasn't designed and documented exactly from the beginning the way that the standards written 30 years ago specified. So we took a novel approach with our assessor. We achieved that level of functional safety certification. And then just here in January, we announced that we had achieved a much more significant milestone with what's called the mixed criticality certification for the same functional safety requirement. And that has implications for we talked about a little bit earlier with the high performance compute, the consolidation of safety and non-safe workloads on the same compute element. So mixed criticality means that you can demonstrate that you can have freedom from interference of the functional safety applications from the non-safety applications on the same compute platform. So we just achieved that certification, and now we're going for the full certification of the Linux distribution that we offer to the market, the Red Hat in-vehicle operating system. We'll have an announcement later this year on that milestone, but it is a key element of what we're delivering to market, not just open source innovation and modern cloud native development platforms, but maintaining the required functional safety and meeting those stringent requirements. We're really excited about that differentiating factor for us. So it's the pace of innovation. It is the many eyes concept, the speed with which bugs can be fixed, pushed back upstream, security fixes can be closed. This is one aspect of it. The other aspect is now what you have is by nature, organically, you have collaboration between both at-large developers and organizations. You have the ability, and this has been well proven out in other industries as well, where you have foundations, consortia, and this is being established in the last few years in automotive as well. Companies coming together in foundations and working together on what we often refer to as software blueprints, right? So they'll build a common open piece of software to perform some sort of function. And there's so much software that is siloed historically between different companies building the same kinds of, applications, right? But when you start collaborating and combining forces, you can really divide and conquer. You can do so much more if you're not all reinventing the same plumbing, the same infrastructure. So it helps move the whole industry forward faster. And in fact, we submit, and we're really getting good validation of this in our conversations with automakers and tier ones out there, that it's really essential. Open collaboration and open source in order to meet the challenge of the pace of innovation that needs to happen in order to stay competitive and keep up with the insurgents and disruptors. It's really essential that we collaborate. We don't all reinvent the wheel. We work together. And it's really proving out to be the way forward. Lots of activities to that end already happening, and it's growing.
And you're right in that so much software in this industry has been siloed and proprietary. And we have seen what open source unlocked for enterprises in terms of just the pace of innovation and new capabilities from a broader community out there to prove out the solutions. I'm really excited about this trend of open source innovation entering the automotive domain. The other trend that we have seen growing is the real-time over-the-air updates, especially with modern cars and EVs that come embedded with a SIM card for constant connectivity. But beyond just OTA updates, how does this pre-integrated solution fundamentally change the business model for automakers?
Yeah, it's a great opportunity. And I think the automakers are already trying out different sorts of things, subscriptions to certain vehicle functions. The functions themselves have the infrastructure in the vehicle to operate, but they can be turned on or turned off depending on whether the customer, the end user, subscribes to that particular feature in the vehicle. So it's not just about software updates or security fixes, but it's the opportunity for what we refer to as feature on demand or personalization of the vehicle. It also, I think, one of the things that is being looked at is what kinds of remote diagnostics and troubleshooting can be done over the air. connecting to the vehicle from the operations center and using data from the vehicle to interpret what's happening and try and solve problems. So I think it's going to be subscriptions to features on demand, the ability to personalize the vehicle, other kinds of services that if you are in motion in a vehicle, there might be some location-based services that you might want to subscribe to. The possibilities are really endless. And I think there's a great deal of opportunity for new revenue generation throughout the life cycle of the vehicle. That customers will expect the ability to get these sorts of updates, and they can subscribe to different levels of service and capabilities on an ongoing basis. It's really exciting.
But you're right. Features on demand, hyper-personalization, location-based services, the possibilities are endless, really exciting. Beyond just vehicles, there are other industries that are facing similar challenges with increasing software complexity. In your mind, are there lessons learned from this collaboration that could be applied to other sectors beyond automotive, say industrial, manufacturing, or healthcare?
Yes, absolutely. And as a matter of fact, we've been through this before, right? I was a big part of working in open source communities in the telco space 12 to 15 years ago. We started this process of converting. The first step was actually converting from proprietary bespoke operating systems to Linux. And that was a very successful effort. And then there was what was called the software-defined networking initiative and network function virtualization. So that was the whole concept of, again, separating hardware from software, being able to work in concert with the entire supply chain, the telcos, the equipment manufacturers, the ISVs, and consulting organizations and system integrators to build common open building blocks for the necessary software stack between the applications and the operating system, right? It was the same scenario. There's so much common software that wasn't truly differentiating. And so they went through this whole process and completely reimagined and improved, the pace of innovation, the ability to combine efforts, to move faster, to have open building blocks that could be shared, and then moving into more cloud. The next thing that happened after that is they started with sort of brute force virtualization techniques, hardware virtualization, and moved on to cloud native technologies. And this was really coming back to the whole OTA discussion that we had a few minutes ago. The ability to containerize and package applications as container. There's a lot of details in the technology, but the bottom line is you can really create more fine-grained software modules, and the serviceability aspect of that, the safety of updates, can be increased in addition to containerized applications use less memory and are just easier to update and safer, right? So there's a lot of opportunities there. And so that industry did it before. There was a lot of lessons learned about how to do that correctly. And part of it was having the management buy-in for open collaboration. One of the things that happens when new industries are starting to work with open source is there's sort of a hesitance to contribute too much or give up the special sauce, and the reluctance to say, well, this is differentiating or this is not differentiating, right? And so it took a while for telcos to really, and some of the suppliers, to have the right mindset and the right behavior and learn the benefits of open collaboration. And I think that the automotive industry could learn a lot from those lessons learned. And we're definitely advising some of these communities on how to do this right. So, and it is happening in industrial as well. So the whole OT transformation in automation is transforming as well. So it's really exciting.
I love the idea about fine-grained software modules with open source collaboration across the sectors. It's such a promising domain for innovation and new applications for personalized experiences. So thank you so much, Bob, for your time and insights. And that's it for today's episode on the OnCloud podcast. If you enjoyed this discussion, be sure to subscribe and leave us a review. You can also check out our past episodes wherever you listen to your favorite podcast. Thank you for listening to the OnCloud podcast. Until next time, I'm Gary Arora.
This podcast is produced by Deloitte. The views and opinions expressed by podcast speakers and guests are solely their own and do not reflect the opinions of Deloitte. This podcast provides general information only and is not intended to constitute advice or services of any kind. For additional information about Deloitte, go to deloitte.com/about.